July 2nd, 2019, 1342, Coordinated Universal Time, Cloudflare deploys a seemingly clean single web application firewall, or WAF rule. Just 3 minutes later, on-call phones across the globe scream. Across the entire planet, Cloudflare's CPU usage instantly hit 100%. This spike, or CPU exhaustion, led to traffic dropping by 82%, effectively taking down major services like Coinbase, Discord, and Shopify. This was not a hack, nor was it a cut fiber cable. It was a single line of text, a regular expression, or regex. This internal error caused a catastrophic backtracking loop, melting the control plane. To understand the extent of the damage, we must consider the architecture. Cloudflare sits in front of 26 million internet properties globally, with traffic first hitting their edge nodes. These edge nodes handle tasks like decrypting SSL, content caching, and filtering attacks using the WAF, essentially acting as a bouncer. The WAF checks incoming HTTP requests against known attack signatures. In 2019, the WAF was written in Lua and utilized a library called PCRE, or Perl Compatible Regular Expressions. PCRE is the culprit responsible for the incident. Let's trace the kill chain. At 1342, an engineer deployed a new rule to block cross-site scripting, or XSS, attacks. This was standard procedure. By 1345, network operations saw massive packet loss, and by 1352, it was clear to Cloudflare London that this was a global issue. The CPUs were not just busy, they were locked. The WAF consumed every available cycle, preventing the processing of even the SSH commands needed to kill the service. This locked the control plane. Regular expressions typically use linear scanning to check a string, moving from left to right to find a match. This is generally efficient, showing linear time complexity, ON, where the time increases proportionally to the data input size, N. However, PCRE includes a feature called backtracking. Backtracking allows the engine to revert and attempt different combinations if a match fails. While this offers flexibility, it can be fatal if quantifiers are nested. The exact code that caused the issue involved nested quantifiers, specifically a sequence shown on screen, followed by a construct including wildcards. The problem was the wildcard trap, a wildcard inside a capturing group followed by another wildcard. This structure created a catastrophic backtracking scenario. When a malicious string hit this regex, the match failed, and the engine backtracked. Due to the nested wildcards, the number of combinations the CPU had to check grew exponentially, with a growth factor of 2 to the power of n. For a string of only 20 characters, this exponential growth forced the CPU to execute hundreds of thousands of steps. Cloudflare dealt with millions of such requests. Every single core, on every server, entered an infinite loop simultaneously. The system failed due to complexity, not volume, leading to a global meltdown. The immediate fix was a global kill. Engineers disabled the entire WAF-managed rule set to restore traffic. For a systemic fix, they changed the engine, migrating from PCRE to Google's RE2. RE2 guarantees linear time execution and does not support backtracking, preventing this type of failure. Cloudflare also introduced sandboxing. No single WAF rule is now permitted to consume more than a set amount of CPU time before being forcibly terminated, such as a 10-millisecond limit. The key lesson here is to never trust a regex you copied blindly. A production safety checklist is available for download in the description to help prevent this exact failure before your next deployment. We analyze a new corporate system failure every week. If you want to understand the architecture of disaster, subscribe. Do not become the engineer we cover next.